another concept on something called type 1 and type 2 errors. Now, effectively, what we are saying is that if we by mistake reject the null hypothesis when it is actually correct. So null hypothesis was true, but by mistake we reject it, that's known as a type 1 error. If we mistakenly fail to reject the null hypothesis, this is known as a type 2 error. So we should have rejected it, but we have selected it rather. So if you see this grid, there are only two possibilities with the hypothesis. It could be either true or it could be false, and you can probably accept it or reject it, correct? So if the null hypothesis is true and you have not rejected it, which means you have accepted it, that is a correct decision. If the null hypothesis is false and you have rejected the null hypothesis, that is also a correct decision. But if the null hypothesis is true and you have rejected it, this is a type 1 error. If the null hypothesis was false and you have accepted it, this is a type 2 error. Fine. Now let's understand what this means. The probability of type 1 error is given by alpha. Remember yesterday we had seen the significance level. So 1 minus alpha was the degree of confidence. Alpha is the level of significance for the test. This alpha is the probability of type 1 error. So when we are looking at 95% confidence intervals, the probability of type 1 error is 5%. Fine. Now we can reduce this probability of type 1 error by reducing the significance level, which means I can reduce the alpha value to 1%, which brings my confidence level to 99%. This, however, would start including bigger values because I would have increased the band, correct? Instead of the earlier band, which is given by the dashed line, I have now increased the band size by giving a 99% confidence interval. This effectively would tell me that the probability of type 2 error, which means a null hypothesis that should have been actually rejected, is now not getting rejected. So if I reduce the probability of type 1 error, the probability of type 2 error will go up because I have increased the band. Effectively, I will include some values here that ideally I should have rejected, but now I will accept them effectively, correct? So if I reduce the probability of type 1 error by increasing the confidence level or reducing the level of significance, which is given by sigma, then I will increase the probability of type 2 error. Conversely, if I increase the probability of type 1 error, or let's say I want to reduce the probability of type 1 error, I will tighten these type 2 error, I will tighten these bands. So now type 2 error probability will go down, but at the same time alpha will go up, which will increase the probability of type 1 error. So they are kind of, mutually against each other. And to simultaneously reduce these probabilities of both these errors, the only thing that you have in your hand is to increase the sample size. That would give you a better estimate of data in general. So as you keep increasing the sample size, the simultaneous probability of these two will go down. Simultaneous reduction in the probability of these two, type 1 and type 2 errors. Fine. That's